Salam sejahtera to my first panel, TS Dr. Ahmad Fuad bin Abdul Ghani, and my second panel, TS Abdul Kahar bin Nardin. My name is Constantine bin Sindhu. My matrix number B0919104666, and I'm from the course BMMM Maintenance from Section 1. My supervisor is TS Dr. Nofariza binti Abdul Wahab. The title for my bachelor degree project 1 is Improvement of Vacuum Block Design Using Computer-Aided Engineering CAE Analysis. This is my presentation outline. First of all is introduction, followed up by problem statement, objective, scope of study, and literature review. After that, methodology, then result and discussion, that is analysis result. Lastly is conclusion. This is my introduction. So my introduction more involved in manufacturing application, vacuum clamping system, and vacuum block. First is manufacturing applications. In manufacturing systems, fixtures such as clamp are an important part of the material removal process. For example, machining process. The vacuum clamp is one of the fixtures used widely in manufacturing industries. So the vacuum clamping technologies are provided to ensure there is no damage when using this clamp system, which any of the scratches or clamping marks on the workpiece. So when comparing this vacuum clamping technology to the others clamping systems such as mechanical clamping system, there's more benefit of it. The give you some example of the mechanical clamping system, which is G clamp. When G clamp on the workpiece, there is leave damage, scratch of the clamping marks on the workpiece. So that is not very good for the finishing of the workpiece, not very good quality for the workpiece of the certain product. So that's the benefit of the vacuum comparing to the others. Okay, continue for the vacuum clamping system. Vacuum clamping system is about how the vacuum clamping system works. So assume that there is air or atmospheric pressure is the same in all direction, force acting in all direction. So in vacuum clamping, there is a negative pressure that is formed underneath the clamp object. So that is what it means by vacuum pressure is less than atmosphere pressure. When there is when the vacuum pressure is less than atmospheric pressure, the atmospheric pressure will push on the vacuum pressure, but is the lower pressure. So means that the air pressure is constantly lower than in the atmosphere. Thus, atmospheric pressure forces the workpiece against the vacuum clamping block. What keeps the uh, workpiece push always stay on the clamping block is because the suction force operates the vacuum clamp. The vacuum pump keeps the workpiece secure in place. The vacuum clamping concept is typically used primarily to hold the workpiece, which is on the flat surface products only. Okay, next is the vacuum blocks. So the vacuum blocks is actually more relatable to my project title, which is the designing of the new shape or any forms of vacuum blocks. So the vacuum locks, which keeps the workpiece in place, that is one of the most important pieces of the vacuum clamping system. The vacuum block uses pneumatic suction to retain materials or workpiece during machining. The vacuum block is portable, which is the lighter the material used, the easier it will carry. My problem statement is first thing is lack of SolidWorks study CAE analysis utilizing on multiple shapes. That is from the previous project performed. The lack of SolidWorks study CAE analysis apply on the multiple shapes. Next is the vacuum clamping block is not suitable for clamping odd workpiece form, according to a prior project study. Limited shapes design from the previous one, only the more focus on the square and hollow shapes only. Last, Lastly is no single study analysis for different vacuum block shapes. My objective for my PSM is first is to study the static analysis and flow analysis towards vacuum blocks in SolidWorks analysis. Second, to design 3 new vacuum block shape by using SolidWorks software. Third, to simulate analysis of the 3 new vacuum block shapes design. My scope of project is focused on vacuum blocks employing 3 shapes of layering material with the same parameters to acquire flow and static analysis using SolidWorks software simulation. Then SolidWorks will then be developed and evaluate the vacuum blocks design. The Delrin vacuum blocks will be assembled using computer-aided design models. After sketching and designing vacuum block parts, computer-aided design models are evaluated using engineering drawings. Lastly, simulation is used to check the design. This is my literature review. So my literature review is focused on the previous design of vacuum blocks. So this uh, previous design has been performed from the previous PSM student. So I'm using them as a reference for my comparison to design new shapes of my vacuum blocks. So my focus parameters for this literature review from the previous design is to focus more on shapes, size, and materials. This is my methodology. So this my methodology give an overview of how my flow projects uh, works. So this is my flow chart. It will begin from the start and then proceed to design of vacuum blocks. In designing of vacuum blocks, I will continue on creating 3 new shapes. I'm choosing the circle, hexagon, and octagon. After that, after choosing the 3 new shapes, proceed to do run analysis. So static analysis and flow analysis. Static analysis focus on von Mises stresses, strain, and factor of safety. For flow analysis, focus on velocity, pressure, and temperature. So when after running the analysis, it will give some best output result. When it meets my expectation desired result, it will proceed to computer-aided manufacturing CAM process, then fabricating, testing, and end. When it not meets my expectation result, I will have to come back to designing of new vacuum block again. This is my experimental method works. It will begin from sketching. After sketching, creation of 3D modeling and detail drawing, that is from the SolidWorks software. Then proceed to simulation, static analysis, flow analysis, and lastly is comparison analysis data. This is my design of new vacuum blocks in SolidWorks software. So this is the output result of the sketch drawing and 3D shape model of the three new vacuum blocks. There is some fixed parameter has to be kept in order to reference of the previous vacuum block. That is the thickness, number of holes, and volume of suction of air. After completing the designing of the new shape of vacuum blocks, I will then continue on the static analysis. This is how the static analysis process perform. It is from first thing is creating simulation study, followed up by material selection of the vacuum block. This is using by their rain material. Then fixed geometry selection to make the vacuum block in fixed condition, stay in one position only. Then apply external load input parameter and load selected area. Then meshing the model. Lastly is generating the result. As for flow analysis process works first on to creating of new simulation project, that is wizard, followed up by parameter setting, then define leads to enclose the inlet and outputs. Then set the boundary condition, run the study, and generating results. So generating result used my uh, for my evaluating result of flow analysis is flow trajectories 1. This is my result and discussion. So this part is more focused on static analysis result for factor of safety distribution for the color region. Blue color indicates for safe region and red color indicates for unsafe region. Means that for unsafe region means that the value is less than 1, and safe region indicates value larger than 1. When the value is larger than 1, that is unsafe region, means that some areas of part of the point or design have a weakness spot. Means when it is larger color for red unsafe region, we have to redesign or make a new change of the parameters of the design. Overall, uh, through static simulation, stress, strain, and factor of safety, the result give me acceptable outputs, uh, and the force load tested is 10 Newton force. This is my flow analysis result, and this part is focused on the velocity level. On the highest air velocity value or level on the inlet and the suction area. So I'm using the model color contour to compare between the three sample shapes. The setup pressure I'm using, this setup parameter is 70 kilopascal. As you can see, there is the output of the maximum velocity of the inlet or inside the vacuum block flow, and the the velocity with the consistent high outputs desired makes the quick operation setup and for maintenance purpose selection for me to using which shape is desirable. This is flow analysis result, and this part is focused on the pressure. So the same setup parameter is using is 70 kilopascal. As you can see, there is the maximum and minimum of output of the pressure between the three shapes. So this pressure simulation is to focus on the highest pressure value on the suction area. When it is the highest, As you can see, this octagon, that is a desired output to make sure the workpiece stayed fixed and for machining purpose fusioning. This is flow analysis result focus on the temperature level. So comparison using the model color contour, uh, use comparing the three sample shapes, it indicates average of stable and desirable temperature level, that is low temperature, and when is low temperature, it is desired for the selection of design parameters. All the three sample shape is desired selection output. As a conclusion, no design shapes has been created. The workpiece with fixed parameter has been tested through simulation. An ideal output outcomes for static analysis and flow analysis has been established. For future work or study, I will continue on the comparison through static analysis based on different force other than 10 Newton. Uh, After that, comparison through flow analysis based on different pressure other than 70 kilopascal. We'll then continue on evaluation comparison through static analysis based on 10 Newton, flow analysis based on pressure 70 kilopascal as a reference. That is all from me for my slide presentation for PSM1. Thank you.